Welcome class to our lesson on DC circuits. This is part of a bigger series on electrical trade theory in Zimbabwe. So the first item that we want to discuss is the types of current that we have. So we have DC current, which is current that only flows in one direction. Then we have AC current, which is pulsating current, which changes direction. So current in general is defined as the rate of change of charge. If we were to use a formula, we are saying current given by capital letter I is equals to charge a Q all over T. So from here, we can also make charge a subject of formula. So charge is equals to current times time. The SI unit for current is amps. The SI unit for charge is coulombs. The SI unit for time is seconds. So down the line, we are likely to meet questions which require application of this formula. So as we move on, let's look at circuit components. So the first basic circuit component that we are going to discuss is a fixed resistor. So a fixed resistor impedes the flow of current, or limit the amount of current in a circuit. Then an alternative symbol is shown here with a zigzag sign. Then we have a variable resistor. So on a variable resistor, we can change the resistance. Then this is the circuit symbol of a cell. A cell produces EMF. Then this is the circuit symbol of a battery. A battery contains two or more cells. Then we have a circuit symbol for a switch. A switch, it opens or closes the circuit. Then we have a circuit symbol for a filament lamp, which converts electrical energy to light. Then we have a fuse, which is a protection device, which protects the circuit components from overcurrent or short circuit current. Then we have an ammeter. An ammeter is used to measure the amount of current in a circuit, and it's always connected in series. Then we have a voltmeter, which is used to measure voltage. Then the voltmeter is always connected in parallel. From there, let's define the Ohm's law. So the Ohm's law states that current is directly proportional to voltage and inversely proportional to resistance. So if we were to write this as a formula, we're saying that current, a capital letter I, is directly proportional to voltage V and inversely proportional to resistance R. Okay, so you are expected to be able to define this formula. Either you're expected to be able to define the Ohm's law either by using a formula or by simply stating that current is directly proportional to voltage and inversely proportional to current. So from this formula, we can make voltage subject to formula. So V is equals to IR. We can also make a R subject to formula. So resistance is equals to voltage over current. So we are done with Ohm's law. Let's move on to resistor networks. So on resistor networks, we're going to start by looking at the series network. So on the series network, the total resistance Okay, so let's look at resistor networks. The first network we're going to look at is the series network. So for a series network, the current which goes through the components is the same. What differs is the voltage. So to calculate the total resistance, we use a formula. So we're saying RT is equals to R1 plus R2 plus R3. So this is the formula for resistors in series. So RT is equals to 4 ohms plus 9 ohms plus 11 ohms. So in total, our resistance for this circuit is 24 ohms. Okay. Then this is the total resistance. So to calculate the current in the circuit, we just use Ohm's law. So current is equals to voltage over total resistance. So current is equals to the voltage, which is given as 12 volts, over the total resistance, which is 24. So the current in this circuit is equals to 0.5 amps, isn't it? It's equals to 0.5 amps. Okay, so we are done with a series networks. Let's move on to parallel networks. So on parallel networks, the simplest situation that we can have is a situation whereby we have only two resistors in parallel. So if we have a situation whereby we only have two resistors in parallel, to calculate the total resistance, we just say total resistance RT is equivalent to R1 times R2 all over R1 plus R2. So simply we are saying that for only two resistors, the total resistance is given by product over sum, isn't it? Product over sum. So RT is equals to R1 is 3, R2 is 6, then all over the sum, which is 3 plus 6. So 3 times 6 is equivalent to 18. 3 plus 6, that is 9, isn't it? So here the total resistance will be at 2 ohms. So that's how we calculate the total resistance in a parallel circuit, isn't it? In a case whereby we only have two resistors. But we can also have a situation whereby we have more than two resistors. So if we have more than two resistors, to calculate the resistance of the circuit, we use this formula, 1 over a RT. 1 over RT is equals to 1 over R1 a plus 1 over R2 a plus 1 over R3. So this formula can be extended to R4, R5, R6, isn't it? Then so it, 1 over RT is equals to 1 over R1. Our R1, our first resistance here, it's 10, isn't it? Then plus 1 over R2, our second resistance here is 20. Then plus a 1 over R3, our third resistance is 30. So what we now need to do, we need to add these three fractions together. So to add these three fractions together, first of all, we just select a common denominator. So our common denominator here is 60. Then 10 goes 6 times into 60. So it's 6 times 1. So it's 6 here. 20 goes 3 times into 60. So it's 3 times 1, which is 3. Then 30 goes 2 times into 60. So it's 2 times 1, which is 2. Okay, then we add the values on the numerator. So if we add our values on the numerator, we get 1 over RT is being equals to 6 plus 3, which is 9, plus 2, which is 11. 11 over 60. Okay, then to actually get the value of RT, we need to invert both sides. So I'll invert the left-hand side. So it's RT over 1. Then if I invert the right-hand side, it's 60 divided by 11. So 60 divided by 11 it's equals to 5.45 ohms. Okay, so we have dealt with resistors in parallel. Now let's look at combination circuits. So our next circuit on the left-hand side here, it's a combination circuit because we have some resistors which are in series and some resistors which are in parallel. So what we can see is that R2 and R3 are in parallel. So let's find the parallel resistance for R2 and R3. So I'll say a resistance in parallel is equals to because we only have two resistors, so we can say product over sum. So we say R2 times R3, then all over at the sum, which is R2 plus R3. So if we substitute values, R2 is 8, R3 is 3, then so R2 is actually 6. So R2 is 6, then R3 is 2, then the sum is 6 plus 2. So if we simplify this, this is like a 12 over 8. So 12 over 8, it's equivalent to 1.5. Okay. Then the other resistors, they are connected in series. So the formula for total resistance, RT is equals to R1 A plus the parallel resistance A plus a R4. So here we are saying that the total resistance RT is equals to R1, which is 2.5, A plus R parallel, which is 1.5, then plus R4, which is 4. So if we add this together, we get 8 ohms as the total resistance. Okay, I hope you've managed to understand this lesson on DC circuits. So to fully understand everything that we're talking about here, you need your own textbooks. So in the description link below, I have links to various textbooks that are going to give you a much clearer picture of DC circuits